Welcome. What are we doing? We are going to do some abacus and hello. Welcome everybody, welcome. My name is Lynette. We are the day after 4th of July, so July 5th. So what we're going to do is we're going to do some abacus. We're going to read the abacus. After we read the abacus, we're going to understand how to add, subtract, and you can actually do multiplication and division on the abacus. Yes, you can. Yes, you can. But the first thing we want to do is I want to show you how to use the abacus. We're going to read the abacus. When we read the abacus, we're going to understand that we're going to look at the numbers. We have our answers. We have our numbers. We have our answers. Welcome, welcome, welcome. So what we're going to do is here's the number, which is 284. So this number is 284. What we want to do is we want to bring it down to here. And I'm going to put in 284. 284. 100, 200. And then I have 80. 50, 60, 70, 80. And then 4. 1, 2, 3, 4. 1, 2, 3, 4. And then that is what we call 284. Let's see if I can do this. There we go, 284. So I'm going to color in 200. So my hundreds, right? 100, 200, 80, 50, 60, 70, 80, and then 4. 1, 2, 3, 4. And then we can do it again. So here's my next number. Welcome everybody, welcome. My name is Lynette. We are working on the abacus. We're learning how to read the abacus. Welcome everybody. Let's see, I need to bring this down. Thank you everybody, thank you. So what are we going to do? We're going to take this number over here and we're going to color it into here. Now what does that mean? So 860, 0, 800, 5, 6, 7, 8, 60, 50, 60, and then 0. So we have 800, 500, 600, 700, 800, and then we have 60, 50, 60, and then the 0. 0 just means that it is a, it's that there's none of the beads that are being, there's none of the beads that's being counted. So the counted is where the horizontal bar is touching. The beads are touching this horizontal bar. When the beads are touching the horizontal bar, that's what's being counted. When we look, we have 800, 500, 600, 700, 800, and then 60, 50, 60, and then 0. So that's what this number is. Our next number takes us over here. We have 113. 113, if you notice, is 100 is my hundreds. 100, and then another 100, 100, and then 13. 3, 1, 2, 3. Welcome everybody, welcome. What we're doing is we're learning how to read the abacus, and this is not working. All right, so I got to end this one. So, welcome. So what we're doing is we're learning how to read the abacus. When we learn how to read the abacus, we are going to color it in. So we color in 100 and 13, 10 and 3, 1, 2, 3. 113, that's what 113 looks like. And it takes me to this box over here. This box, because I'm doing a reverse maze, it takes this number and we put it into here. So now we need this number and we got to put it into this box over here. So when we're reading, we have 100, no, we have 6. This is my ones. This is my ones place because this is my ones. I have 5, 6. Welcome, welcome. Thank you, Russell. Thank you so much. So what we're doing is we're reading the abacus. We have 5 and then 6, and that's it. So what are we doing? We're reading the abacus. It's hundreds, tens, and ones. When we look, every column is a place value. So we have our ones, our tens, and our hundreds. That might make a little bit more sense. But that's why we have 3 digits. Every column is a digit. So then we next have our next question. Our next question is over here. We have 223. 223 looks like this. 233. That's what 233 looks like. 233 looks like that. And I'm just going to close this out. Okay. 233. We have our hundreds, right? That's what it looks like. Hundreds, tens, and ones. That's what it looks like. Hundreds, tens, and ones. I don't need to look at that. Good morning. Good morning, everybody. Good morning. Happy. Thank you so much for the rose, Web. Thank you so much for the rose. What we're doing is we're learning how to read the abacus. We have 233. So 200, this is my hundreds. This is my tens. 10, 20, 30, and then 3. 1, 2, 3. Welcome, everybody. Welcome. Good morning. Good morning. Good morning, good evening, good afternoon. I don't know where everybody is in the world, but Good morning, good evening, good afternoon. Hello, everybody. Happy 4th. The day after. Boxing, Independence, happy Boxing Day. Happy Independence Boxing Day. I don't know. That doesn't make sense. Anyways, so we have this number, and now we're going to go to here. Thank you so much. Thank you so much, Avery. Welcome back. So we have 884. It takes us to here. So we have 800, which is 500, 600, 700, 800, right? So 800 looks like this on the abacus. 5, 6, 7, 8. We have our tens, right? Our 10, our 50, 60, 70, 80, and then we have 4. 1, 2, 3, 4. Good morning. Good morning. Have I been up all night? No, Avery, I have not. But it feels like it, doesn't it? So we're going to do 97. 97 looks like this. What are we doing? We're doing 97. 97, we have our tens and we have our ones. So 97 is going to go into here. We have 90, 50, 60, 70, 80, 90, and then 5, 6, 7. Every column is a place value. So I'm going to color in my abacus. I have 50, 60, 70, 80, 90, and then I have 7. 5, 6, 7. And that's 97. This is my hundreds. This is my 9. Hello. Good morning, everybody. Good morning, good evening, good afternoon. We have 471. 471 goes into here. We have 471. Good morning, Celeste. 471 looks like that. 471. 400, 100, 200, 300, 400, and then 70, 50, 60, 70, and then 1. We have 471. Oop, 1. There we go. That's a mistake. Because it's a reverse maze, I give you the path, and you're going to have to follow the path and then tell me what this number is. This number is 872. 872 on the abacus looks like what? 872. Welcome, everybody. Welcome. Thank you so much. Thank you so much, Celeste, for the rose, and Mel. Thank you so much for the rose. So let me know if we're after this. It'll be your turn. But what I want to do is I want to show you how to read the abacus. So we have our 800, so 500, 600, 700, 800, 70, 50, 60, 70, and 2. 1, 2. Notice the top beat is a value of 5, right? Anytime the top beat touches this horizontal bar, that's what's being counted. So every beat that's being touching the horizontal bar, the reckoning bar, is being counted. So these columns over here there's none of the beats touching. These are all zeros. So the only one that's available right now is this one, 2, 7, 8. So, good morning, everybody. Good. Oh, no, sorry, wrong one, wrong way. So we have our next number, which is 715. So we have to take 715 and we got to put it into here. 715 looks like what? 715 looks like this. 715. 5, 6, 7, 1. All the lower beads has the value of 1, and then there's the top bead. The top bead is a value of 5. So when I'm looking at 715, I'm going to color in 700, 500, 600, 700. 15 is 1 and a 5. This is 715. How are we doing? Hello, everybody. Hello. Good morning. Good morning. Good morning. So our next number is 144. 144. We have our hundreds, our tens, our ones. We have our hundreds, our tens, and our ones. This is 144. Notice none of the top beads are touching the horizontal bar. Because, why? Because it's not being counted. Because it's not being counted, we don't need to count it. So this is where we get 144. We're going to color in 144. And then our last number is here. Oh, hey, Hunter, my 4th was pretty fun. It was really fun. Thank you for asking. How was your 4th? I'm happy you're safe. So we have 745. 745. I live by a park, so we were able to see the park's fireworks. So that was kind of cool. So we have 500, 600, 700. We got to do 700. And then 40, 10, 20, 30, 40. And then 5. 5. That's what 745 looks like. Are we ready? Are you ready to... It is now going to be your turn. So what we did is we worked on a reverse maze. This is my reverse maze. I give you the number and I give you the path. All you got to do is figure out what the numbers are and you got to color it in. So it went, oh, hey, that's cool. You went to a rave? I love raves, but I'm too old for those. I love raves. I like that kind of music. Who is playing? Anybody special? So this is my book. Thank you everybody for joining. Thank you everybody for joining. If you're looking for this book, it is not available. There's another one that's available in my TikTok shop. It is a 2-digit one. The 2-digit one looks like this. This one is a specific one, is a 3-digit one. And I didn't add it to my TikTok shop yet. Oh, right, because I added the bundle. That's why. So there is this one where it's the same, and but it's only working on 2 digits. So we have our 10s and our 1s. If you're looking for more books, I have more Abacus books available. I also have it available over here. My name is Lynette. Hello, everybody. Hello. So what we're going to do is we're going to figure out how to do more mazes. Just to give you a little review, we have the reverse maze in the 2-digit, and it's the same thing. I give you the number, and you need to color it in. Obviously, I've already colored it in, so I've already gone through this. And then now what we're going to do is we're going to do an actual maze. So I'm going to give you the number, and you're going to tell me what it is. Are we ready? Welcome, everybody. Welcome. Oh, I'm waiting for my next book. Okay. Yep, I have another book coming in. It's going to be a 4-digit, but for right now, we're going to do 3-digit. And what are we going to do? I need to find, I need to find my cover. Is it here? Oh, here it is. All right, so what we're going to do is over here, we're going to look at this number, and we're going to figure out what number this is. What do you think this number is? Can this be math in any, it's used for really arithmetic. So it's a lot about just adding, subtracting, multiplication, and division. As long as you can do any of this, it's easy to do. And what it is, it's a very visual. So that's what I'm trying to show you, is that it's a very visual thing. But yeah, it can be used for math, but not any kind of math, if that makes sense, Kendrick. Did that make sense? Thank you for asking. That was a really good question. 833. Oh, yeah. Thank you. Thank you. Thank you, Hunter. Thank you, Heather. Yes, we're going to do our hundreds, our tens, and our ones. Well done. Well done. Did that make sense, Kendrick? That was a good question. So yes, it is 833. So we have our next number. We have our hundreds, our tens, and our ones. Did that make sense? No, that doesn't right. That's not right. There we go. Our hundreds, our tens, and our ones. What number do we think that is? Thank you. Thank you, Heather. Thank you. Yes. 350, right? 7. 5, 6, 7. Well done, Hunter. Thank you so much. 357 takes me down to here. And now I'm over here. And then we have what number? We have our hundreds. We have our hundreds, our tens, and our ones. We have our hundreds, our tens, and our ones. What number do we think that is? We have our hundreds, 862. Well done, Hunter. Thank you, Kendrick. Almost, Kendrick, almost. 72 looks like this. Thank you, Claire. 62 looks like that. So what we're doing is we're looking at the beads, right, and looking at the position of the beads. So that's the difference. But well done. Good job. So we have 862 takes me up to here, and this is my next number. So we have this number. We have our hundreds, tens, and ones. We have our hundreds, tens, and ones. What number do you think that is? Good morning, good morning, good morning, and thank you everybody for joining. Hello, hello, hello. Oh, that didn't go on. What am I trying to pin? This one? What's that pin? Oh, 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 oh. Yes, thank you. It is 780. Well done. Yes, because we have 700, 500, 600, 700. We have 80, 5, 6, 7, 8, 10, 50, 60, 70, 80, and then 0. Well done. Thank you, Mary. Thank you, Kendrick. We have 780. And then we have this number. What number do we think that is? So we have our hundreds and we have our tens. So we have our hundreds and we have our tens. What number do we think that is? Well done, everybody. Thank you. 600. Thank you, James. Welcome back. Thank you, Kendrick. Yes. Thank you, Claire. Yes, 610. Easy. 610. And it takes me down to here. And now we're down here. So what number do we think that is? We have our hundreds. I'm going to color it in. We have our tens. And we have our ones. We have our hundreds, our tens, and our ones. What number? Almost, amazing James. Almost. 400, 100, 200, 300, 400. You got that. You have to have the top bead is 5. Thank you, Hunter. And this is 50. And then we have 9. 5, 6, 7, 8, 9. Thank you, Kendrick. Does that make sense, James? Well done. Okay, thank you, Hunter. Thank you, Kendrick. We have 409, 59, and then we have our next number. We have our hundreds, our tens, and our ones. Oh, that one's easy. What number is that? What is our next number? Is that the same? Oh, yes, it is 958. Well done, Kendrick. Well done, James. Good job. So we have, thank you. Thank you.
I love it. Great stuff.
So we have our hundreds, our tens, and our ones. We have our hundreds, our tens, and our ones. I don't get it. Well, I just said it. Hundreds. And what number is it? Thank you, James. It's 300. 1, 2, 3. 0. None of the beads are touching the column. And then we have 7. Thank you, Kendrick. Thank you, Hunter. Thank you, James. We have 5, 6, 7. And so what we're going to do is we're reading 307. Now I have a next number. What is our next number? There we go. There we go. So we have our next number. We have our hundreds. And we have our tens. And we have our ones. So we have our hundreds, our tens, and our ones. What does the line mean? This line right here, this is the reckoning bar. Anytime the beads are touching the reckoning bar, that's being counted. So James said this is 452. Well done. 400, 1, 2, 3, 4. This is 50, and then 2, 5, 1, 2. So just kind of take a look. Because these beads are not touching, these are all zeros. So that's not being counted. So we have 452. 452. Thank you. Thank you, James. So we have our next number. We have our hundreds, our tens, and our ones. Thank you for actively watching. Asking questions is the greatest thing because then I know you're actively looking and trying to understand. That is what's very helpful. Thank you. Thank you, Jazzy. So we have 195. Well done. 100. Thank you, Red Drum. Yes. Thank you, Mary. Thank you, Will. Cry and Will. So we have 195. 195. 1, 9, 5, 6, 7, 8, 9, and then 5. So when you look, we have our top bead is touching the horizontal bar, the reckoning bar. This is counted. But the top bead will always be the value of 5, no matter what. So then we have this number. We have our hundreds, our tens, and our ones. What number do we think that is? We have our hundreds, tens, and ones. What number? How do people do math with this, though? 86. Well, that's what we're going to get to. We're going to get to adding and subtracting. But the first thing we do is we understand how to read the abacus. Yes, thank you. Thank you, Red. Thank you, PH. Yes, thank you, Will. It is 86. 5, 6, 7, 8, 6. 5, 6. Well done. 86, and it takes me over here. And that's what we're going to do next. We're going to learn how to remove the beads, and then we're going to start adding and subtracting. So we have our hundreds, our tens, and our ones. Hundreds, tens, and ones. That's what we're doing. What number do you think? Thank you, Hunter. No, it's not 7. It's 6. Thank you. Thank you, Red. Thank you, Cry. Yep. 406. Okay, so it seems like we're ready to, we're going to be ready to do some what? We're going to start learning how to move the abacus. This is where we're going to start doing adding and subtracting. Now, the first thing we're going to do is understand how to move the beads. Notice that what we're going to do is, welcome everybody. Notice that what we're going to do is we're going to hold the abacus. The abacus is very easy to move the beads. If you notice, if I just do this, that's why you want to use your left hand to stabilize it. I'm actually enjoying this. Oh, good, Desi, good. We're going to continue on, and we're going to continue on because abacus can actually help you with adding, subtracting, multiplication, and division. But thank you so much. I appreciate that you're here. I hope that you were able to understand some of the numbers. So, this book here, I don't have it yet available, but I do have a 2-digit abacus book available. And what we're doing here is, again, the same thing, but we're doing 2 digits, and this has already been done in my previous lives. What we're doing here is we're understanding how to read the 2 digits on the abacus, and we just color it in, we do the same thing. And again, I still have a reverse maze. This reverse maze here, hello, good morning, good evening, Lady E, right? Good evening. It's been a little bit. So this is my reverse maze. I give you the path, and you just need to tell me what the numbers is, and that's what this means. So what we're going to do now is we're going to understand how to move the beads. Again, we're using your left hand to stabilize the abacus. You use your right hand to do the calculations. Now, if you notice that I actually have 2 dots. There's one here and there's one here. Notice that there's dots. So if you choose this one over here,
Pokemon, I choose you!
Then I'd have my label of ones. This is my label. This labels tells me that this is the ones place. So this is the ones, the tens. So when we're counting, we're going to review 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 10, 20, 30, 40, 50, 60, 70, 80, 90. But now I have no more room for 100. So that's why I would choose this one over here.
Okay, Charizard, I choose you!
Because I choose this one over here, I'm just going to move everything over like that. So now I have my ones, my tens, my hundreds, my thousands, my 10,000. And what we're doing is we're learning how to read the abacus. As we go through, we're going to understand how to move the beads. So again, when we move the beads, we want to just use the edge of the beads, right? Because you notice that there's a point, there's an edge to it. So you just need to brush the top part. And then you just move the beads. They're very easy to move. You don't need to be aggressive. You just need to be gentle. So when we're doing it, you don't need to really dig in. You just need to gently move the beads, just like that. Okay? We want to be gentle and we want to be happy. So what we want to do is we do not want to flick. Excuse me. If you flick, you're going to get the wrong answer. The reason why is because all of the beads will move.
And flick. Oh, you flicked too hard, damn it!
Don't flick. Okay? So what we're going to do is we're going to move the beads with intention. If I have the 5, I add the 2. So then my final answer is 7. So what we're doing next is we're going to start understanding how to move the beads. And that's where this book comes into play. This book was meant for children from 3, 4, and 5, for preschoolers. I was kind of gearing towards preschoolers, for those kids that don't know how to read numbers and those that don't know how to write the numbers. And that's what this one is. And so if we're looking, this is just a little flip through. I have activities in the book where we talk about the 1, we talk about the 0, there's tracing, and then it just goes through each of the numbers. And I just need to try to find what the numbers are. So there's tracing this number 4. Then there's activities to support it. So after the activities, right, we have our maze. This maze, they could choose any path, but the idea was to find the maze and to find the number. And then we can do it again. We have a matching over here, and then pixel art. And then after that, we have lesson 2. Lesson 2 goes from 0 to 9, and I give you instructions in the beginning too, just in case, right? So it looks like that. We have instructions. We have, this is what it looks like on the abacus, and this is what it looks like as a picture. So we have 5, 6, 7. So 7 on the abacus is what I showed you. That's what 7 on the abacus looks like. That's what I tried to do here. So we're just flipping through, and then we only go up to 9 because I didn't want to have to talk about the place values. What we're doing is we're just doing a flip through of this book that is available in my TikTok shop. If you're interested, I do also have books available over here. My name is Lynette. Hello, I am an Abacus teacher. So, thank you again for all of the gifts. Thank you so much for the gifts. So, the next pages or the lessons is we start talking about how to count forward, and then after we start counting forward, we learn how to count backwards. Oh, this is still counting forward. This is counting backwards, and then this is just activities on how to count backwards. And then we have what comes in between, and then after what comes in between is what is surrounding, right? What comes before and what comes after. And then after that, we talk about, you know, what comes bigger and what's less than. Okay, so now we're finally getting into the point where we're going to add and subtract. So this is about adding and subtracting. What we're going to do in in Abacus World, what we need to do is we need to focus in on the second number. That's what it is. We got to focus on the second number. When we focus on the second number, we need to understand what? We have our 7 here, we add 7 here. We want to add the 1. Can we add the 1?
Yes, we can.
Yes, we can add the 1. So what we're going to do is we're just going to add the 1. So my final answer is 8. 5, 6, 7, 8. What I did is I moved the beads to the horizontal bar. When I subtract, I move it away from the horizontal bar. You're going to start noticing the number patterns. We add it, right? We subtract. So what we're going to do is we're going to do number 2. Number 2 is the same. So we bring it to, we have 7 on the abacus. We add 7 to the abacus, and then we add 2. Can we add the 2?
Yes, we can.
Yes, we can add the 2. 1, 2, and we just add it. We go to the horizontal bar. So my final answer is 9. So you could do this. You could do mainstream. Mainstream is they do dots or they do tallies, which is fine. It's up to you. But I like to do the abacus way because we can count. 5 plus 3 is 8. Now, if you look, it's easy to supertize. Supertizing means that you can look at the number and you know what it is. I know that this is 8. I know this is 9. I know this is 6. I know this is 7, right? 5, 6, 7. So going back, I have 5 plus 3 is equal to 8. Because I have 5 plus 3 is equal to 8, then I know what it is. You could do your tally marks, or you could do your tally marks, or you could do your dots. Now, if you notice with the dots, it's kind of a little bit difficult to see, so you would have to break it up like 4 plus 4, which is fine. But now it gets to a point, it's like, well, let's kind of do it one step further, which is what? We want to scale it. When I scale it, what if I said I want to plus 50 plus 30? I add the 50 plus the 30, my answer is 80. You could do the tally marks, which is fine, or you could do the dots. That's fine too, but that's a whole lot of dots and a whole lot of tally marks. Let's take it one step higher. I want to do 500 plus 300. My answer is 800. So what we're doing is, I'm showing you that abacus is scalable because this is a representation of the number, whereas this is a one-to-one. This one-to-one is very difficult to manage. When we look, you can do 500 tally marks and then 300 tally marks, and then you could do 500 dots and 300 dots. You could do that. Or I could do the abacus and it's just more scalable. So I know that this is going to be 8, and I know that this is 800 because I'm starting here as my ones, tens, hundreds. I know this is 8. We could do it one more time, right? We could do it one more time. We could do 5,000 plus 3,000, and then we get 8,000. All right. So that's the difference between doing the dots and doing the tally marks. Now the next one is adding the 4. When we add the 4, we're just moving the whole bead up, whole bead down. That's it. All up, all down. That's it. And so after that, now we know how to subtract. Because you know how to add, you will know how to subtract. The way I've broken up the book is I want to focus on the add-in. I want to know, can I add the 1? Or can I subtract the 1? So my question is 2. I want to take away 1. Can I do it? Yes, I can. So I'm going to take away the 1. Now, what are we going to do? We can do 2. 2 is the same thing, right? I have 3 on my abacus, and I want to take away 2. Can I take away the 2? Yes, I can take away the 2. So what we're doing is we're understanding how to move the beads, and that's what moving the beads, and it's the same thing with the 3. And then we go all the way to 5. 5, we do is we add. We have 3 on the abacus, we add the 5. That's it. We add the 5, take away the 5. Add the 5, take away the 5. So what we're doing is we're understanding that when you add, you go to the horizontal bar. When you subtract, you go away from the horizontal bar. Hello, everybody. Hello. Welcome, welcome, welcome. If you're interested in this book, this is my preschool abacus book, and we talk a little bit about the relationships of the numbers, and we talk about adding and subtracting. But the first thing you'll notice that when I'm adding, it's all easy stuff, right? We have enough numbers. We have 1, and then we want to add the 6. When we add the 6, we want to bring it together like that. When we want to take away the 6, we push it apart like that. If you're interested, I do have my books available in the TikTok shop, or it is available here. Hello, my name is Lynette. Thank you for joining me. Please, for those of you that are joining me, please keep your mind open.
Now, open your mind to me, please. Open your mind.
Abacus is not a new method. It is just a forgotten tool. It's a forgotten method. And I am here to help you understand what it's all about. And so what we're doing is we're understanding how to move the beads. And also, as we learn how to move the beads, we're learning how to read the abacus. So what we're doing is I'm going to do 1 plus 8. Excuse me. I have the 1. I'm going to add the 8. 5, 6, 7, 8. I'm going to add it together, and I got to take it apart. So I add add the 8, take away the 8. If I add the 8, I take away the 8. So what we do is we understand, just like in Karate Kid, you know how to put your jacket on, you know how to take your jacket off. So that's what we're doing. So we put it on, we add the 8, we take away the 8. And that's it. And then we can do it again with the 9. And then we just did the subtraction, which is what we did already. So we have 7, right, plus the 1. And then minus the 5. Minus the 5 is take it away. And that's it. Welcome, everybody. Welcome. My name. Hello, honeybee. Thank you for the follow. Hello, my name is Lynette. Thank you so much for joining. And that's it. That's it. Well, what's the question? What's the next question? The next question is, what happens when you don't have enough? Because you don't have enough, we have these things. We have these formulas. We have this concept that we can actually utilize. There's a concept that we can utilize, and the concept is how to make a 5. This making of the 5 is actually a really interesting concept, because once you understand your fundamental concept, you will be able to understand how to add and subtract. That's all we're doing. We're just doing arithmetic. That's all we're doing. So what's being pinned is this one right here. Okay, so this is my Abacus formula book, which means that I'm just, this is a dry erase book, and what we're going to do is we're going to understand how to utilize this concept. This concept is, what is it called? It's a addition sentence. Addition sentence? It's a math fact. This math fact that we see is 1 and 4 is a math fact. When we look, we can do our number bonds. We know 5 and 4, right, are pairs. And then they're going to be interchangeable. So what we're going to do is, what are we doing with this 4? Well, we have our question. Let's see if this helps. We're going to do with this one first. Okay. What we're going to do is we're going to understand this. We have 1 plus 1. When we have the 1, and I'm going to use this one over here, this location. We have the 1. Is there enough? So what we want to do is we want to focus on the added. Do we have enough over the second number? Yes, we have enough. And so my final answer is 2. Well, we could do it again with this 2. If I have 2 and I want to add a 1, right? I'm looking at this second number. Can I add the 1? Yes, I can add the 1. So my answer is 3. I can do it again. I can add the 3 and I want to add the 1. To add the 1, I'm just going to, do I have enough? Yes, I have enough. Okay, so here's my final one. Here's I want to add the 4. I already have 4 on my abacus. I want to add the 1. There's not enough beads to add the 1. But guess what? That's where this concept of how to add the 5. What does that mean? I know my 1 is a pair for the 4. So what I'm going to do is I'm going to add the 5, take away the 4. And then my final answer is 4. No, I'm sorry, my final answer is 5. So what did I do? There's a formula. I just switched it out. So I add the 5 and I take away the 4. So my final answer is 5. I don't know if that made sense. We can do it again. So here's another way to understand. It kind of makes sense, but it kind of doesn't make sense. I understand. So let's do it again. Here we want to do is we have our math fact. Our math fact is 4 plus 1 is equal to 5. So what I'm going to do is I'm going to put 4 on the abacus. Thank you, Izzy. So what we're going to do is we're going to put 4 on the abacus. Because we put 4 on the abacus, I'm going to use, oh, not that. I'm going to use 4 on my abacus. So here, I'm going to do 4 on my abacus. Let me put pennies down, right? 1, 2, 3, 4. 1, 2, 3, 4. So this is 4 and this 4, right? They're the same. This 4 is the same as this 4. What I want to do is I want to add this 4. This is the 4 I want to add, but guess what? I don't have any more pennies. So what I'm going to do is I have a nickel. Because I have a nickel, guess what? I'm going to add my nickel, but that's too much. I need to take away 1. So I take away 1. My answer is what? 5, 6, 7, 8. I could do it again on my abacus. I can add my 5, and I take away the 1. So my answer is 8. 5, 6, 7, 8. That's it. So we could do it again with this question. When we look at this, right, we have 3. 3 on my abacus. 1, 2, 3. I can do 3 pennies. 1, 2, 3. Now I want to add the 4. To add the 4, I don't have any more loose pennies. I don't have any more pennies. I don't have any more beads. So guess what, though? I do have 5 cents. Because I have 5 cents, I'm going to trade it in. But that's too much because I'm only looking at the 4. What am I going to do? I'm going to take away the 1. So my final answer is 7. 5, 6, 7. I can show you again on my abacus. I add the 5 and I take away the 1. So my final answer is 7. 5, 6, 7. Izzy, did that make sense? So what we're doing is we're understanding this concept of the 4 and the 1. And how does it make a 5? We're utilizing the 5, which is the top bead. This top bead is what we're going to be adding and subtracting. So the blue beads are 1s. Yes, yes, Zene. Yes, the blue bead is always the, yeah, I was trying something new. Thank you, Izzy, for letting me know. Yeah, the blue bead is always 5, and the bottom beads are always 1. So this is, if you want to be poetic, the top bead is heaven beads, the bottom beads are the earth beads. So when we're looking, we can count 5, 6, 7, 8, 9. And then this would be 10. Every column is a place value. I have my 1s, my 10s, my 100s, my 1000s, my 10,000s. Yeah, I think it makes more sense with the money. That's funny. Snuffle abacus. That's so funny. Okay, so let's do it again with the 2. Right? What I'm doing is I'm also showing you how to practice it. So, and if you notice, if I have the 2 and you look at the abacus, there's not enough beads. Guess what? I have my nickel. To give you my nickel, that's too much. I need change back. You need to give me back 1. So I take away the 1. I could show you again on my abacus. I add the 5 and I take away the 1. So my final answer is 6.
Oh, I love it. Great stuff.
So we could do it again with this 1, right? Thank you, Fernando. I do like that snuffa abacus. So I have the 1. I have 1. But again, I want to add the 4. Because I have no more beads to add 4, I only have 3. I need to provide this 5. Because this 5 is more than enough, I can add my 5, but I need to take away 1. So then I'm left with 5. My final answer is 5. I can add the 5, take away the 1. So my final answer is 5. See? And so what we're doing is we have this concept. This concept is 4 plus 1 is equal to 5. We do 3 plus 2. We could do 3 plus 2. 3 plus 2 is again a different type, is the same concept but different numbers. But you'll notice there's only three questions that will warrant the formula. So my question is 4. I'm going to add 4 to my abacus. Oh, that's not right. There we go. I add 4 to my abacus. I have 4 to my abacus. Hold on. Okay, I add 4 to my abacus. 1, 2, 3, 4, right? I have 4 on my abacus. And then what do? I want to add the 3. But I don't have any more beads to add the 3. Guess what? I have my 5 cents. That's too much. I need to do what? I need to take away the 2, right? I take away the 2. So my final answer is 7. 5, 6, 7. I could show you again on my abacus. I add the 5, take away the 2, and my final answer is 7. How do you read the abacus? Do the colors mean any different? No, they don't mean anything different. But thank you, Kellogg's, for the question. So if I replaced it with this, it's exactly the same. So when we're looking, we have 1, 2, 3, 4. This is 1, 2, 3, 4. The top bead comes down. When the top bead comes down and it's only the top bead, you have 5. Notice the bottom beads are not touching. These are all zeros. This is 0, this is 0. The only top bead is touching. That's 5. So when I have 6, we have one top bead and one bottom bead. That's 6. How do I know? 5, 6. Now we can count, right? We can count up. 5, 6. 1 plus 5 is 6. So we have 7. This is 7. 2 plus 5 is 7. 2 plus 5 is 7. So what we're doing is we're also being able to decompose. As we decompose, we know what numbers are inside it. So this is 3 and 5 is 8. 3 and 5 is 8. 8, 8. And then 9. 4 plus 5 is 9. 4 plus 5 is 9. Did that make sense, Kellogg? So, thank you everybody. Thank you everybody for joining. My name is Lynette and I teach the abacus. If you're interested, I have books available at my TikTok shop. I also have it available here. I sell the abacus on my website. And I think I did it right. Did I pin it? I pinned it. Yeah. Thank you, Kellogg's, for the question. So if anybody's interested, I do have these abacus. And what we're doing is we're learning how to read and understand how to use the abacus because I believe it's a forgotten tool. All right. What's next? We're going to continue on. We're going to do 3 plus 3. Again, we don't need to memorize what 3 plus 3 is because that's not scalable. Now, when we're looking at it, we have 3 on the abacus. I have 3 on the abacus. That's what 3 looks like. 1, 2, 3. Oh, no, can't see that. Okay, so when we add 3 on the abacus, there we go. When we add 3 on the abacus, I don't have any more beads to add the 3. I don't have any more beads, so what I do, I have this concept. I know I can add a 5, but that's too much. So what do? I need to take away 2. So my final answer is 6. 5, 6. I can do it again on the abacus. I can add the 5, and I can take away the 2 to give me 6. How are we doing? Does that make sense? So, can we do it with the 2? Yeah, we can do it again with the 2. And we'll show you. I will show you. I will show you.
Come on, do it. Do it.
So we have 2 on the abacus. I have 2 on my abacus. There it is. 1, 2. I'm going to add 3. When I add 3, oh, sorry, I can't see it. When I add 3, there's not enough, right? But guess what? I have this nickel. We might as well use whatever we have, right? I don't need to find more pennies. Let me use what I have. I'm going to give you my 5 cents, but that's too much. I need to take 2 back. So now my final answer is just back in time. So, what I did is I added the 5 and take away the 2. So what we're doing is we're understanding this concept. The concept is how to make a 5. How do we utilize this 5? What we did is we took the add-in. The second number is this second number. The second number is what we're trying to understand. It tells us and it dictates what we're going to do. Can we add 3? Right? So this is the question. If I add 1, can I add 3? Yes. I don't need to use the formula. I just do 1, 2, 3 because I have enough beads. It gets to a point when I don't have enough. I need to do this, or 3. I need to utilize this 5. Now I'm going to be counting, right? So what we did is we took this number sentence, and what we did is we modified it. We did some modification.
You need modification! Modify! Modify!
So what we did is we isolated the variable. I don't know if you can see that. We isolate the variable. What is the variable we isolated? Now we're doing a little bit about algebra. We isolated this variable right here. We did the 3 because we're looking for the 3. This is what we're looking for, this 3. We can actually substitute this information. We go 3 is equal to plus the 5 minus 2. That's what we did. We added the 5. So we took this information and we substituted for 3. So we replaced the 3 with the 5 minus 2. And that's what we did. We want to add the 5 and take away the 2. So what I'm doing is I'm also giving you directions on how to move the beads. You add the 5 and you take away the 2. So your final answer is 6. We can do it again with the 4, right? So I have 4 on my abacus. There we go. We have 4. We have 4. 1, 2, 3, 4. I want to add the 3. To add the 3, what do? Plus the 3 is what? Equals to plus the 5 minus 2. So we're going to plus the 5, right? Take away the 2. 1, 2. So let me show you how. Oh, whoa. Wow, let me show you how it's scalable. We know this. So here is my question. 26 plus 32. We have 20, we have 6. There it is on my abacus, right? And what we need to do is we need to add 30 and 2. We're going to add the 2, so we add the 2. There's enough, right? Is there enough? Yeah, there's enough. I have these 2. I'm going to add enough. Now I need to add the 3. Notice on my abacus I don't have enough to add the 3. 1, 2. I only have 2 to add. I need to do 3. So I'm going to utilize the 5 and then take away the 2. So my final answer is 58. We can do it again with this number over here. So I have 1,000, and now what I'm doing is I'm showing you how it's scalable. It's scalable because what? Because it's scalable because we understand the fundamentals. So that's what we're doing. So we have 1,357. We don't need to do friendly numbers. What we need to do is understand the columns and what they provide for us. So here's the question. We had to add 2. We want to add 2 to this column right here. Can I do it? Yes, I have enough to add the 2, so I'm just going to add it, right? Now I have 4. Can I add the 4? No, I cannot add the 4. Do you remember what the formula is to add the 4? We're going to have to utilize the 5. Does anybody remember how to add the 4? How do we add the 4? Do we know what it is?
Come on, do it. Do it.
What is the formula to add the 4? Anybody knows? Almost. Adding the 4. The 4's partner is 1. So we're going to do plus the 5, take away the 1. So what we do is we understand that this partner of 4 is actually 1. So we're adding the 5 and we take away the 1. Does that make sense, Hunter? So when we do the 3, is there enough to add the 3? Yes, there's enough. I'm going to add the 3. And then we have the 1. Is there enough? Yes, add the 1. And so what we're going to do is my final answer is 3,788. Thank you, Delgano. Delganaco. Thank you. Yes, bring down the 5. But you got to take away the 1 because we're adding the 4. So what we're doing is we're understanding the concept, and now it's scalable. I kind of get it. Yeah, you almost got it. You almost got it. It's just that we have to practice on the relationship of the numbers. When we look, 4 and 1 are the pairs. 3 and 2 is the pair. So when we're looking, 5, right? There's a 3 over here and a 2 over here. This is the number bond. This is the relationship. Yeah. Yeah. So when we're looking, that's what we got. That's the only thing. As long as you remember who the pairs are, we can do it. So let's continue on. Oh my gosh. Let's continue on. And so I wanted to solidify the concept of how to make a 4, how to make a 5. The reason why is because once we understand how to make a 5, then we can go into how to carry on, right? And so what we're doing is we already did the maze here, but then we have a color by number. So this is an activity. This is my workbook. This is my Abacus workbook. And what we're doing is we're understanding how to make a 5. I have all of these activities to make a 5. Thank you everybody for joining. It is available in my shop. I also have the Abacus available as well. If you're interested, I do have it available. I do have another collection of books over here. Hello, my name is Lynette. Thank you everybody for joining. Thank you everybody for joining. Hello. Okay, cool. So we're going to continue on with adding, right? So we have our add the 5. When we add the 5, we're going to, what are we going to do? We can color by number. We can, oh, you know what? We'll do this. So we have our making of the 8. Oh, so here's a question. Can I add the 8? Yes, I'm going to add the 8. Can I take away the 5? Yeah, I can take away the 5. So my answer is 3. I'm going to put my answer. 3. Okay, that's not a thing. So here it is. 3 plus 3. Here's my next number. 3, 1, 2, 3, and I want to add another 3. How do I add another 3? To add the 3, let me know in the chat how to add the 3. Thank you everybody for joining. Thank you everybody for joining. My name is Lynette and we're doing Abacus. We're learning how to add and subtract on the Abacus right now. So what would be the formula to add the 3? To add the 3 is, yes, thank you, Hunter. It is plus the 5 minus the 2, because the 2 and the 3 are the pairs. So we want to plus the 5, take away the 2. So my final answer is 6. So we could do it again over here, right? And then if you notice, we just need to practice, and we're just learning it. So we have the 4, same thing. If I have the 4 and I want to add the 3, guess what? Plus the 3 is equal to plus the 5 minus 2. So I want to plus the 5, take away the 2. My final answer is 7, right? And then we get this. So 5, do we need to do a formula for this? I have the 5 and I need to add the 4. Do I need the formula? No. Thank you, Corey. Yes. Right? So my final answer is 9. Okay, that's no. Okay, so we have 9 and then take away 7. Can I take away the 7? Yes, I can take away the 7. 5, 6, 7, take it away. Just like that. So my final answer is 2. Here's the next one. 4 plus 4. Do I have enough beads to add the 4? No, I don't. What would be my formula to add the 4? Thank you everybody for joining. What would be my formula to add the 4? What can I do? What can I do? I want to plus the 4 is what? Thank you, Hunter. Yes, right? Plus the 4 is equal to plus the 5 minus the 1. Thank you, Corey. Plus the 5, take away the 1. So my final answer is 8. That's it. So now we understand how to add the 5, right? And then I have like a whole activity. This is color by number. We have tic-tac-toe. There's normal number bonds. There's more mazes and tic-tac-toe, right? And then there's color by, and then there's word problems. So this is a little also a walkthrough, a flip through of my book. And if you're ever interested, I do have this I have the answers. So now we understand how to add the 5. Now what's going to happen is we're going to subtract the 5. That is where this book comes in. We're now going to subtract the 5. It's the same concept, but now we're doing in reverse order. So hello everybody, welcome, welcome, welcome. My name is Lynette and I am an Abacus teacher. Thank you everybody for joining. Here is the book. Where's the book? This one right here. Okay, cool. So how are we doing? Make sense? So what we're going to do is now we're going to do is subtract the 5. Because we know how to add, we will know how to subtract. Why would we want to do that? We want to do that because the questions. It's all about the second number. It's all about the second number. So here's my number, 8. So if I have 8 on my abacus, I want to take away 4. Again, we're not going to memorize our doubles. What we're going to do is memorize our concept. We know what? If I have 4, I know I'm going to take away the 5 plus the 1. So I have 8 on my abacus, and I need to take away the 5. I'm sorry, take away the 4, because that's the question, minus the 4. Minus the 4 is what? Minus the 5 plus the 1. So my final answer is 4. And then we could do it again over here. This is a spin the wheel, and you use a paper clip. Hi, Char! Paper clip, and you spin it, and wherever the number lands, that's where you put it. So this is an odd, and I put my number over here, odd. And then we would solve the question, right? So my question is 7, and I want to minus the 4. How do I minus the 4? To minus the 4 is what? Minus the 4, let me know in the chat what minus the 4 is. Thank you, Char. Minus the 4 is equal to minus the 5 plus the 1, which is very different than what we learned from before. So when we were talking, right? Thank you, Char. When we did the adding of the 4, what did we do? Plus the 4 is equal to plus the 5 minus 1. See how see how this is different? The only difference is the operation. So we have minus the 4, minus the 5, and plus the 1. So if you look, we have minus the 5 plus the 1. So now we're going to look at the number pattern. We have minus the 4, add the 4, plus the 4, minus the 4. Does that make sense? Thank you, Char. Thank you, proofapparel.shop. How are we doing? So we're going to continue on with the subtraction. Now again, what we're going to do is, this is the concept. We understand that 4 and 1 is a pair. We know that 4 and 1 is a pair. That's what this is, right? 4 plus 1 is equal to 5. What we're trying to do is we're trying to make a 5. So we have this concept, 4 plus 1 is equal to 5. And then we can actually utilize it on the abacus. We can do it again with the 15. I have 1, I have 5, and I want to take away 4. I don't have enough beads to take away the 4. What do? We have to minus the 5, and then plus the 1. And then my final answer is 11. Good morning, Deceptive. Good morning. Or good evening, good afternoon. it's yeah. So, and then I just have tic-tac-toe, and then we could do it again with the 3. When we minus the 3, it's the same thing, because we know how to add the 3, right? We did 3, and we want to add the 3. We did plus the 5 minus the 2. Now, what we're going to do is we're going to have 7, and we need to minus the 3. Minus 3 is what? Minus the 5 plus the 2. So what I like to do is I like to make sure that I understand the chant. Minus the 5 plus the 2. Whatever you say, just do. Minus the 5 plus the 2, and my final answer is 4. Make sense? So we could do it again. Again, this is my spin the wheel. You spin the wheel on the paper clip, and then you answer the question. So I have 16 on my abacus. There are 16. Oh. 16 on the abacus, and then we want to take away the 3. Take away the 3 is what? Is there enough? No. Minus the 3 is what? Minus the 5 plus the 2. Minus the 5 plus the 2. These are just directions. Right? Does that make sense? So when we're looking, we have 16 minus 3. And then my final answer is 13. We can do it again. We can do it again with the 2. Right? So with the 2, we have 6. And we want to take away the 2. To take away the 2 is what? Minus the 5 plus the 3. Make sense? Cool. So then, what are we doing? Oh, so that's it. So we can also do it again with the 1. When we do the 1, what is the formula for 1? Minus the 5 plus the 4. We have 15. And then we can minus the 5 plus the 4. Minus the 1. Is there enough? No, there's not enough. Minus the 5 plus the 4. So my final answer is 14. That's it. How are we done? Are we done? Okay, we can do the next one. So the next one, right, there's more to it. The next stage, the next phase is how to make a 10. When you make a 10, it's the same thing. The concept is very similar. We know we need to understand how to make a 10. So 5 and 5 is a 10, 2 and 8 is a 10, 3 and 7 is a 10, 4 and 6 is a 10, and 1 and 9 is a 10. Yeah? So that's why I start with the 5, because it's a little bit smaller. Making a 10 is also just as easy, and we'll go into it. So if anybody's interested, I do have these available in the shop. There we go. So this one is my minus the 5, and you'll notice I have like, it's like about 100 pages, and I also give you the answers in the back. And just in case you don't understand. But then the idea was to strengthen and understand the concept, the basic concept of adding 5 and taking away the 5. Thank you, Supreme. Thank you, Supreme. So that is minus the 5. Now what we're going to do is we're going to add the 10. Whew, adding of the 10. What does that mean? Well, what we're going to do is we're going to add the 10. Adding the 10 is like carrying over, carrying on, which is actually quite interesting. Because I was talking about it and I was like, oh, that's brilliant. Okay. So, thank you everybody for joining. Hello, my name is Lynette. Let's do a review on what an abacus is. This is an abacus, and this is a counting tool. When we count, let's do a review. 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. That's all we're doing. So when we're looking, we have 10. This is 1 and a 0. How do I know that that's 1 and 0? Every column is a place value, right? So we have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. And that's it. So when we're looking, we have 11 is 1 and 1. 12, 13, 14, and then 15. We have 16, right? 16 is 1 and a 6. 17, 1 and 7. And then 18, 1, 18. And then 19, 1 and 9. And that's it. So how are we doing? Woo! We went back up to 100 people. a whole lot of people left. I'm not sure if a whole lot of people left or it's not counted. Okay, so YS. I don't know what S means. So when we're looking, right, we have our decimal. The decimal sits between our ones and our tenths. And then we have our tenths and then our hundreds. We can do ones, tens, hundreds, thousands, 10,000s. So if you notice, there's a little indicator right here. This indicator tells me where my ones will be. So if I choose this one over here,
Pokemon, I choose you!
I will shift everything over, and now this will be my label. When I have my label, I have my 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is it started in the middle? What are the last two on the right? Oh, yeah. Hey, Kay. Yeah. So the last two on the right was the tenths place. Did that make sense? I know you were probably typing as I just switched over. I think I read your mind. So what happens is the decimal sits between the ones and the tenths. So now we have our decimals over here. So we have our tenths, hundreds, thousands, 10,000s, and then 100,000s. So now we can count. This is 9, and then we do 10, right? 1 and 10, ones and tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, but then there's no more room for hundreds. So that's why I choose this one over here.
Okay, Charizard, I choose you!
So what's going to happen is I'm going to use this as my ones place. I move everything over, so now I have more room. I have my ones, my tens, my hundreds, my thousands, my 10,000s. So this is adjustable, is what I would call it. And when we have our decimal, the decimal sits between our tenths and our ones and our tenths. So now we have our tenths and our hundreds. Okay, did that make sense? So when we're looking at the abacus, we can actually count, and we're going to do a review. Wait, look forward for a TED Talk. Keep it up. Thank you. You know what? Deceptive, it's going to get really good because I started talking about, oh my God. Okay, you know what? I'm going to tell you right now. I made this revelation, and it's like beautiful. It's so beautiful. Oh my God. So I was doing a comparison. I was talking to another parent. I was doing comparison about adding and subtracting, and it was really crazy. So I'm so happy you were here. Okay. So we had the question, right? We had the question 27 minus 9, right? So what do? In mainstream, you cross this out, you make this 1, and then you make this a 7. What do you have to do? You have to know that this is 17. How do I make 17? You have to know that 8 plus 9 is equal to 17. So one of the math facts that the kids have to know in mainstream math is that 7 and 9, right? 8 and 9 make 17. Okay, yeah, knowledge of this is going to be great. So we bring it down. Okay, that's fine. But then, oh yeah, I like these pens too. Yeah, it's like factoring. Factoring, yeah, they call it fact families, factors, right? Fact family, factors, right? Fact family, factors. Okay, that's fine. That's fine. Fine. Abacus, what do we do in abacus? We know what? We know to minus the 9 is equal to minus the 10 plus the 1. This is what we have to do. We have to memorize this in abacus. This is A for abacus. A for abacus, like A plus. So then, this is mainstream. Mainstream, they have to know this bond, which is fine. You can memorize this. That is up to you. Let's scale it. Let's scale it. Let's do 36 minus 9. Guess what? You're going to have to do the same thing. Minus the 10, which is 2, and then this is 16. So now you need to know that 5, right? No, 7, 6, 7, 7. 7, and then 2. So you need to know that 16 is equal to what? 9 and 7, right? You need to memorize this. This is the fact family that you need to memorize. Abacus, what do? Minus the 9, minus the 10, plus the 1. This is brilliant. This is brilliant. I'm going to make a whole post about it. This is going to be fun. This is going to be so fun. So we do it again. Let's do it again. We do 48 minus 9. We know what? Minus the 10, right? Oh, sorry. Take away the 3, add the 10 here. So what do? We know that 9. We need to know that 18 is 9 plus 9. Guess what? What do we do in abacus? I don't need to memorize this. I just need to know minus the 9 is equal to minus the 10 plus the 1. I know, right? Right, Char? That was my my epiphany. I was talking to a parent about it, and we were just kind of going through it, and I'm like, oh my God, you know how I'm super lazy. I'm not gonna lie. I'm like lazy. That's a lot of memorizing. I don't wanna memorize all of this. I'm just gonna memorize this little thing, because it's always about this. It's always about the second number. And it was like brilliant. I was like, oh my God, why are we teaching to memorize when we have this concept? Make a 10. Awesome, fine, I'm excited. Yeah. It's only because you kept talking about the TED Talk, and I'm just trying to make more of my TED Talk. But it was like, oh my God, right? Like, holy cow, we could do it again. What's another one? Let's do it. Let's do 15, right? 55. 55 and 9. I mean, we could do it again. We could do it again. We'll do it like with an 8. We'll do it with an 8. So right? Take away the 4 and then add the 5. So what do? We need to know that 15 is what? 8 and 7, right? 8 and 7. So 7 and 47. But guess what? Right? Guess what? Abacus minus the 8 is equal to minus the 10 plus the 2. That's all we need to do. Oh, that rhymed. That's the secret. So we don't need to memorize all this crap that's all this here. We just need to know this part here. And I'm just going to break it down one by one. 1, 1, 1, 1. That's it. Look, it's a template. Right, Char? Oh my God, deceptive. Oh, it was brilliant. I was like, oh my God. So basically it's algebra. It is. It's very basic algebra. It's known variables, right? For algebra, we have unknown variables. But this one is a known variable, right? These are all variables. Yeah. So what this would be the variable that we're trying to do. Oh, yeah. So thank you everybody for joining, and I just went off on a little tangent, but I was so excited. I was like, oh my God. Why is mainstream math so complicated? It's a lot of memorizing. And so now, because you know the fundamentals of this, then you can actually have more room to talk about, interest rates. Like, how do you find an interest rate? So one of my friends, Audrey, she is a algebra teacher, and she was talking about how do you find, where is it? I had it. She was talking about how to find the interest rate. And so here, I don't know if you were here for that one. You only need to memorize anything up to 10. Yes! All you need to do is know how to add the 10 and how to add the 5. That's all you need to do. You only need to know how to add the 5 and how to add the 10. That's it. Yeah, I'm really lazy. I'd rather do this and then try to work my way through. Yeah, multiplication, and then there's division as well. We can also do division. Yep. Not up to 10. You only need to know your 10 family. Your fact family of 10s. That's all you need to know. You don't need to know your fact family of 9. You just need to know your fact family of 10. That's the difference. It's a little bit of a nuance, but that's the difference. You just need to know your fact family 10. How do you make a 10? How do you make a 5? So my thought process was, so my friend was talking about how to find the interest rate, and that's a higher concept. This is above my pay grade. I'm not teaching this, but what I'm doing is multiplication up to 9. Yes, thank you, Char. Yes, you only need to know multiplication up to 9. So she was just doing like, how do you find the interest rate? And then she started going through, and I'm like, oh my God, I could do this all on my abacus. So we did the subtraction, we did the multiplication, and then we did the division, and that's it. So, but that's a little bit about, that's a little bit about abacus and how it's scalable. It's scalable because once you know the fundamentals like this, then it'll be easy. But yeah, this one was crazy, and I was like, oh my God, like, because that's the problem, right? The problem is my kids didn't have any problems, so I never helped them with their homework when it came to basic arithmetic. So they just used, if they didn't know this, right? If they didn't know this, they would just always go back to the abacus, and that always helped them. I'm a little rocky on division. Oh yeah, that's okay. We will go through division. It just depends on how many people are in the room. Hello, Lydia. Thank you so much for dropping by. Thank you, Max. Thank you, Max, for the follow. So for those of you that don't understand, we're going to be reading the abacus. So we're going to count 1, very exciting. I look forward to your post. I'm going to go adult name. I'll see you later, Deceptive. Okay, 1, 2, 3, 4. This is 4, and then we have 5. The toppy will always be 5, and then we have 6, 7, 8, 9. After 9, we have 10. We have 10. 1 and 0. How do we know? Each number is a place value. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. That's what we're doing. We can do, Char, we'll do some division because it seems like it's very quiet and nobody's really been asking questions. So we can do division if you want to. I've got some division questions. So, but that's what we're going to do. Yeah? Anybody else here? Bueller, Bueller. Use your brains, not your beads. Ah, oh, Donald. Yippee. Oh, good afternoon. Hey, Cole, Shadow. Yes. Use your brain. That's what we're doing. Oh, thank you. Okay, so we're going to continue on with adding and subtracting. Are we okay with that? Use your brain, not your beads. I'm not sure you're understanding how to use the abacus, but thanks for nothing? I get it. Division is up to 9. Times table as well. Yeah, exactly. Exactly. You only need your multiplication table up to 9. Because after that it gets redundant. We can talk about it. So remember in when we did let's say 9 times 12, right? Let's do 9 times 12. 9 times 12, I mean, you know what 9 times 12 is, right? But when we do it on the abacus, 9 times 12, 12 times 9, 12 times 9, right? So what are we going to do? We do distributive property. So abacus, we do distributive property, means what? We're going to times this, and then we times that, right? So we do 9 times 1 is equal to 9. We got to count our digits, right? 1, 2, 3. 9 times 9 is equal to, so we got to make it a double digit, so it's 0, 9. So 0, 9, 0, 9. So I got to add the 9 here. Oh, yeah. And then what? 9 times 2 is equal to 18, right? We know 18. Right? We need to add the 1, we add the 8. Add the 1, add the 8. To add the 8 is what are we going to do? Thank you. Oh, thank you, Deceptive for subscribing. Oh, thank you so much. So we have the 1 and we add the 8. Add the 1, add the 8. Guess what? Add the 1. We don't have enough. We have to plus the 1 is equal to plus the 10 minus the 9. Plus the 10 minus the 9. And then we add the 8. But that's why we don't do we don't memorize multiplication higher than 10 because it gets redundant. We just do distributive property. And we could do it again, right? Okay, so how are we doing? Are we doing addition or are we going to go into multiplication? So Char, did I show you my multiplication maze? I think we did it, right? Thank you everybody for joining. Thank you everybody for joining. My name is Lynette and we're going to be doing some abacus. So let's do some counting, right? Thank you for the share. Thank you for the follow. Thank you for checking in, Aya. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. This is 10, 1 and 0. We have 11, 12, 13, 14, and then 15. That's all it is. So when we're counting, we have our place values. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. Welcome, everybody. Welcome. What do I want to do? I want to do this one. I have that one, too. Okay. So what are we doing? We can continue on. For those of you who are quiet, let me know. Are we going to continue with adding and subtracting? Like, how do we add? So there's a few things that we need to add. You said multiple. Oh, thank you. Thank you. So this is my prototype. Is it this one? Yeah. This is my prototype. Okay, so the first thing we're going to do is we need to understand multiplication is, you have to know your multiplication table, right? So the idea is after we understand how to add and subtract, we need to multiply. For those of you that don't know how to multiply, we will go into, I'll go slower with the formulas. The formulas that we need to know is understanding how to make a 5 and how to make a 10. Do you have a degree in math or I've just been using Abacus for a very long time. I've been teaching Abacus for about 20 years. And so, And now I'm going down the path of trying to figure out how mainstream math is different than abacus math. And I've come to a lot of realizations. And it's very interesting, very interesting. So again, what we're going to do is we're going to understand that when we do this, right, we need to know our math, our addition table. But I will continue on, yeah? So here is my multiplication, right? Here's my multiplication. This is another maze. And what we're going to do is we'll break it down. So the first thing we're going to do, and I know some of the questions are very easy, but we need to go through it so I can show you the concepts. So here what we're going to do is we're going to understand what? We got to figure out how many digits. Char, we didn't do division? We didn't do multiplication? I thought we did multiplication. So the first thing we're going to do is we're going to count our digits. We're going to count 1, 2, 3. The reason why we're going to count our digits is because we need to understand where to put our number. Where are we going to put our product? Our product on the abacus. We're going to put it in the hundreds. 1, 2, 3. Now the first thing we're going to do is, yeah, okay. Yeah, that's what I thought. But that's the maze. This is the multiplication maze. So we'll do the maze and then we'll do the division. And I think that would be it. Okay, so what we're going to do is we're going to do 5 times 5, right? 5 times 5. We're not going to do 50, right? We're not going to do 5 times 50. Because why? We're already here. My number, my finger is already here. All I need to do is know that I need to do 25. 25, right? Add my 2, add my 5. So my final answer is 250. 250 is over here. I need, what do I need? I need this. 250. Is that one? All right. So it takes me to my next number, which is over here. Now again, we're going to do it again. And what we're doing is we're practicing our multiplication on the abacus. We have 3 digits. How do we know? We count 1, 2, 3. What we're going to do is 3 times 5. I'm sorry, 1, 2, 3. 3 times 5. So we have our 3 is 15. 3 times 5 is equal to 15. So we add my 1, add my 5. 5. And then I need to do 3 times 2. 3 times 2 is equal to 6. 6 is a single digit, so I need to make it a double digit. To make it a double digit, I just need to make it a 0 and a 6. So I go 0 and a 6. Good afternoon, TK. Welcome. So I have 156. Thank you, Char. So my answer is 156. My next number is 22 times 9. So I have 3. 1, 2, 3. Thank you. 9 times 2 is equal to 18. Add the 1, add the 8. Right? Right, Char? Like, it's so easy when you see it on the abacus. And then you do it again. Add the 1, add the 8. So my final answer is 198. Welcome, JP. Welcome. So what we're doing is we're doing multiplication on the abacus. We do 189. So again, that's why we only need to memorize up to 9. Happy Friday. Happy Saturday. Happy Saturday. Happy Saturday, friend. Okay, so we do it again. We have 1, 2, 3. 1, 2, 3. 8 times 9. 8 times 9 is 72. Add the 7, add the 2. And then what do? 8 times 7. 8 times 7 is 56. Add the 5, and then add the 6. So my final answer is what? What's my final answer? Anybody? Is there? Yes, there is an emoji, abacus emoji. When you put in when you put in math or abacus, you'll see it. Even if you put it on your phone. So here. So here, if I did math, do you see that? There's my abacus emoji. Hey, Lily, welcome back. Oh, good, 776. Thank you. Yes, thank you. 776. 776. Thank you, Char. 776. So it takes me over here. Three. 1, 2, 3. 1, 2, 3. 2 times 6 is what? 12. 2 times 3 is 6. 6 again is a single digit, so I go back one column. I need to do 0, 6. 0, 6. So my final answer is, thank you, Char, 126. Again, 3, right? 1, 2, 3. 1, 2, 3. 3 times 2 is 6. 6 is a single digit. Go back one column, add the 6. 3 times 3 is 9. 9 is a single digit. Go back one column. Thank you. 69. Thank you. 69. So it takes me down here. I have 3, right? 1, 2, 3. 6 times 2 is 12. Easy, right? 102. 120. Easy. Okay, so it just seems to be it's just the two of us. Yeah, Lily, are you still here? Oh, good, Lily, you're still here. So we have 3, right? 1, 2, 3. 7, I'm sorry, 5 times 1 is equal to 5. 5 is a single digit. Go back one column, add the 5. No, Char. 5 times 5 is 25. Add the 2, add the 5. Five times 1. Yeah, that's why you have to pay attention to the numbers, right? 5 times 1 is 5. 5 is a single digit, so you go back one column. 75. There we go. 6, right? 6 times 6 is 36. Add the 3, add the 6. 6 times 6 is 36. 6 times 4. 6 times 4 is 24. Add the 2, add the 4. I do, 384. That's funny. 300. Did I not do it? Oh. Oh, I'm over here. Right, there we go. 384. And then we're here. 1, 2, 3. 4 times 8. 4 times 8 is 32. Right? Thank you. 32. 320. Thank you. 32. We're almost done. And then we'll go into division and I'm going to end the live. Yeah? Cool. Thank you everybody for joining. Wow. There's still 29 people here. Okay. What are we doing? 3 digits, right? 1, 2, 3. 1, 2, 3. 6 times 5. 6 times 5 is 30. Add the 3, add the 0. 6 times 4, 9. 6 times 5, 6 times 9. 6 times 9 is 54. Add the 5, add the 4. Thank you. 354. Well done. 354, and our final answer is here. 7 times 4, right? We do 4 again. 1, 2, 3. 7 times 4 is 28. Add the 2, add the 8. 4 times 4 is equal to 16. Add the 1, add the 6. Yes, thank you. 296. Well done. That's it. 296. Okay, so that's the maze, and I'm actually going to increment it. So there's going to be like adding of the 5, adding of the 10, and then mixed formulas. But for right now, this is the beginning parts, and I didn't want to overwhelm anybody, but thank you. Okay, so that's the maze, but you've seen that one. Okay, so let's start doing division. Thank you everybody for joining. Thank you for everybody for joining. My name is Lynette, and I teach Abacus. So, anybody have any other questions about Abacus that I can answer? Anything about that at all? So, Call Shadow, are you still here? So that's the beginning part of the book. And then there'll be more. There'll be more, but I just got to finish my introduction to Abacus Adults. Once I get that out the door, then I'll be set. It's just one of those things. No, this is not division. That's 2 digits. And then this is... All right. So the first thing we're going to do, oh, I gotta find numbers. So we have, hello, Triple J, welcome. Welcome, Triple J, how's it going? Okay, let's see. Thank you so much for sharing my life. I'm looking for questions. Oh, here it is. Nope, that's the wrong one. I have my thinking cap on. Oh, good, because we're going to be doing some division. Are we ready for division? That's not the book. That's not the book. I need to find... Right, there it is. This is the book. Yeah, yippee, division. Yeah, we'll do some division. And then I'm going to end the live. So we're just going to do a couple of division questions. Okay. Excuse me. Alright. I need to find my little... Okay. Again, these are going to be simple, right? Because I don't want to overwhelm. So the first thing we're going to do is we're going to understand our dividend is this one, and our divisor is over here, right? Dividend and divisor. Come on, Char, I need to explain it first before you give me the answer. Right? So what are we going to do? What we need to do, is find our starting point. So our starting point is 2. How do I know? We have 3 dividends, so 3 dividends minus 1 divisor. So when we're right, the questions are simple, but the concept, right? I'm trying to teach the concept. So we're going to do 2. The starting point is 2. 1, 2. I'm going to put my dividend on my answer. So we have my dividend is right here. We have 148. Now what are we going to do? What we need to do is we need to set up our question. Our question is going to be 2 times what is equal to 1. Because 2 times 1 doesn't make sense. This is not part of the multiplication fact. We need to add this extra number. The extra number doesn't come from 0. The extra number comes from here. So we got to bring down that, right? We got to bring that down. So the number we have would be 4. So my question is what times 2 is equal to 14 or less? 7, which is what Char said. Thank you, Char. So we're going to add the 7. That's my quotient. My quotient sits right here, 7. So I have 7 to my number, right? And I add the 7 to my quotient. I take away 14, take away 1, take away 4, take away 1, take away 4. So my next number I look at is 8 times, what times 2 is equal to 8 or less? Because I can divide it, I need to skip this column. I need to skip this column and go over here. So when I skip this column, I go over here. Now my question is what? 2 times what is equal to 8? 2 times 4 is equal to 8. So I put the 4 on the abacus. Thank you, Char. And I take away the 8. And I take away my 8. Take away 5, 6, 7, 8. So my final answer is 74. 74. Now if you look on my abacus, I have my 1s, my 10s, and my 100s. That's why I use my dividend to track my answer. My 1s, my 10s, my 100s, my 1000s, and my 10,000s. So when we're looking, right, that's why I have my dividend on the abacus to help me track the number. Did that make sense, Triple J? I'm not sure if you did division, Triple. Yeah. So we're taking it slow, right? And it's the concept. The concept is what? Understanding how to do long division with the abacus. That's what we do in abacus. We just do long division. And what I did is I broke down the steps. Great, Jellyo Fish. What kind of abacus have you been learning, Jellyo? Is it the 1 and 5? I didn't, but I see the concept. Yeah. Okay, yeah. Yeah, the biggest thing is understanding the concept. So, Jelly-O, I was thinking a few days ago how much I enjoy division. um, long division. Yeah, long division is really made for algebra. I don't know if Jelly-O is still here. What kind of abacus? Oh, okay, good. So how long have you, since 2020, so 5. So you know your multiplication and your division, right? And how did you learn it? Who taught you? How do you use one of those? Hello, Shoebox. So what we're doing is we're going to count. So let's count. 1, 2, 3, 4, 5. And then 6, 7, 8, 9, and then 10. Where is this school or a learning center? Is it, and is there a lot? This is 10. 10, 11, 12, 13, 14, and then 15. 16, 17, 18, 19, and then 20. I am in California. I'm in LA. I'm in LA. Are you in LA? If you're in LA, you'll probably know who I am. Diamond Bar. Oh, so did you go to so you went to a different one, like, I don't know, UMass or something. So, just so you know, I've been creating Abacus worksheets and stuff, but I make it more interactive than what you've, SoCal Mental Math. Oh, I've heard that one. I'm actually out in Monterey Park, but this is my Abacus, and I've been actually making Abacus worksheets, and I have mazes, and I have color by number, and I have instructions, and I have tic-tac-toe. Yeah, I know. I'm really happy with it. Because you know how boring it was, right? It was so boring. My boys, I have 3 boys, and they all went through the old Abacus, and I'm like, that's so boring. So now I have some time, and I actually made some mazes. So this is about bead recognition. So you see the number, and then you just figure out the number. And then here, we have the number, and then you have to find your path. Why did the color switch from... Yeah, mine are just numbers. I know! I'm so sorry. I'm so sorry. But I'm trying to make Abacus more fun. So this one was the hidden word. So you find your answer, and you find and then I can do color by number. I have color by number. I have others. I've been making more Abacus activities. It's been a long time. Lucky, I know. My boys are a little upset. Oh, this one was a good one. I like this one. So this one was a bead. These are petals of a flower. Answer the petals, and then you find the bud. Yeah, and then it gets better. Like, I have like a whole series. Right now I'm up to 10 minus the 10. So I have the adding of the 10. I have adding of the 10, and then I have subtraction of the 10. Oh, that's not it. Where are we? We have subtraction of the 10. And then I have more color by number, and then I'm going to do like 3 digits. I'm going to do 3 digits. So, how many levels are these? This one's all level 1. But I realized that we needed to do more stuff, right? So I did these are all just level 1. They're only doing single digit by single digits by 1 digit, and I go as much as 4 lines. But that's it. But then my next books that I'm going to have is going to do double digits and triple digits. And actually I have a student that's going to do that too. So there will be double digit, triple digit, and then I'm going to do multiplication as well. All right, sorry. Shoe. Yeah, each column is a different value. Thank you, Char. And then yeah. So I'm actually really excited for my books, and now all my books are available either in the TikTok shop or they're available here. Hello, my name is Lynette. Yeah, I'm actually out in Monterey Park. So, yeah. Are all these Abacus level the same? My school starts from 10. You know what? Your school starts from 10, which is the same as starting from 1. Right? And it only goes to 10 levels, which is fine. But what we did is we did it reverse. But what I'm doing is I'm trying to make it mainstream. So when I don't talk about big friends and little friends. I talk about making of the 5 and making of the 10. So when you see it, right? It's like big friends, little friends. Yeah. I didn't use those terminologies because nobody in mainstream understands. So what I was trying to do is I was trying to make it understandable. So then, and it's great. I made some like things. So there's this thing. Oh, the workflow. You don't understand. I made this workflow. Oh, this is beautiful. So there's a workflow, right? There's a workflow. Is there enough? If not, you do this. If not, you do this. And I'm like, this is brilliant. This is everything that we do for adding and subtracting. And that's it. I did big friends. Yeah. So my school, we do family. We do family and friends. Okay, sorry for the digression, but yeah, I'm excited. I'm so excited, Jellyo, for you joining. Thank you so much for joining. I do appreciate talking about Abacus and how you learned it, and I'm just excited for coming down this path and making it more interesting for everybody else. All right, so before I forget, because of my tangent, thank you so much. Yeah, and so Jellyo, what do you think about Abacus? My boys, they didn't like it, obviously, but they do feel that is a benefit. So when we count, let me go back. When we count, hey, Vinters, welcome back. Same as your boy. Yeah. It was such a struggle, and they were like, I don't like this, and I'm like, you got to do it, and I got them to finish it. It's very visual. It is very visual. Yeah. And did you know that Abacus is a little bit like algebra? Did you see this? Have you taken your algebra yet? I'm just going off a tangent. Remember your adding of the friend? Yeah, right? Oh, you've taken your algebra. Did you know that there's algebra inside Abacus? Did you know this? Right? So we do this. Guess what? Let's take it one step back. We do x is equal to plus the 5 minus 1. Right? What happens? You can change this. We do x is equal to plus the 5 minus y. Did you see that, Jellyo? I'm very visual, so it's helpful. Okay, Satan, hold on. I'm just on a tangent right now. Because it's not very often do I see other people that come into my... Yeah, right? Oh my God. And then the cumulative property. I don't know if you were teaching this in cumulative property, but you know what cumulative property is, right? So that's why Abacus is so good. So cumulative property is this. It's different in Abacus. We have this. We can do plus the 5 minus the 1, or minus the 1 plus the 5. You could do the same thing with the tens. That's what cumulative property is. Cumulative property means that you're going to switch the two. Minus the 10 plus the 5, or plus the 1 minus the 10, or minus the 10 plus the 5. So what I'm trying to do is I'm trying to relate it to mainstream math, which is like fascinating. All right. I am off my tangent, but thank you, Jellyo, for commenting, for dropping by. But thank you, yeah? It makes a lot of sense. And I'm like, this is crazy. And then we do substitution. And I'm like, this is what we're doing. We're doing substitution. But again, in Abacus, we don't talk about it that way. We have our different verbiage. All right. I am sorry. I apologize. My name is Lynette. Thank you, everybody, for joining. Okay. Whew. That was a little bit of a tangent. But yeah, it was crazy. Oh, my God. Yeah. So anyways, 1, 2, 3, 4. Thank you, Satan, for dropping by. My name is Lynette. What we're going to do is we're going to understand how to read the Abacus. So we have 1, 2, 3, 4. All the bottom beads is a value of 1. The top bead is a value of 5. So if I use money like this, I can count, right? 1, 1, 2, 2, 3, 3, 4. No, that's not 4. This is 4. That's 4. 4. That's what 4 looks like, right? 4 pennies. 1, 2, 3, 4. 1, 2, 3, 4. 5 will always be the top bead. 5 will always be 5, right? It's always going to be a nickel, no matter what. It was always going to be a nickel. So then what are we going to do? We're going to do 6, right? 5, 6. That's what 6 looks like. 7, that's what 7 looks like. 8, this is what 8 looks like. And then 9, right? 5, 6, 7, 8, 9. I'm sorry. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. And then we have 10. 10, right? 10 is just a dime. That's it. 10. 1, 0. Right? 1, 0. That's it. So when we count 11, 11, right? 12, 13, 14, 15. Ooh, 15, 15, 15. Right? Thank you, Satan. I know. I know. Thank you for being patient with me, Satan. Thank you for being patient and waiting out for my little tangent on talking to other people that understand Abacus. Yeah. So, of course, I nerded out. It gets better. It gets better. Oh my God, Vinters, you're here, right? Vinters, are you here? I did another thing. Oh my God. I don't know if I showed you this. Okay. So, I don't know if Jelio is still here. In mainstream math, let's take this. In mainstream math, you do 27, right? Take away 9. You could do that. Not a problem, right? We do, and then what they do is they tell the kids that they have to memorize 17 is equal to 9 plus 8. Oh, good, Jelio. Guess what? Guess this is what I figured out. So, right, we know that 8 plus 9 is equal to 17. This is what the kids have to memorize. They have to memorize their 9 math fact. But in Abacus, we just need to know minus the 9 is equal to minus the 10 plus the 1. So what do? We have 20, we have 7, right? We have to minus the 10 plus the 1. So my answer is 18. Make sense? So what are we going to do? I can do it again. So we have 36. What do we do on the Abacus? What do we do with mainstream? We need to take the 1, right, is 16. So what do? We know that we have to memorize that 17 plus 9 is equal to 16. So this is what the kids have to memorize. 16 is the same as 9 plus 7. So what happens? Whatever. But in an Abacus, we need to we just do the same formula. Minus the 9 is what? Minus the 10 plus the 1. It's very visual, very visual. It's very interesting. So what do we do in mainstream? Mainstream, we do, again, 48 take away 9. 48 take away 9. What do? We have to do what? We have to cross it out and put in 18. So what do? 48 take away 9. To take away the 9, what do? Sorry to interrupt, but does your center have the advanced books? My books or the boring books? Oh, sorry, let me continue on. So then we have to memorize 8 plus 8 is equal to 18. Okay, that's fine. But in Abacus, we just do this again. So notice the concept is the same concept. Minus the 9 plus the 10. So my final answer is 18. Jelio, what kind of, are you talking about the fun books or are you talking about like the boring books? Because the boring books, we do have it at the center, but we didn't, but it's not published. The ones that I have is the ones here in my TikTok shop or here. My name is Lynette and I'm happy to meet you. So, and it depends on who's it for. Is it for you or for somebody else? Because I'm planning to expand the Abacus curriculum. Yeah. Yeah, the boring books, yeah, we don't publish it out. But because you just do it. Oh, is it for you? Then you just just go through anything and just do it, right? Because you know all the formulas. You don't need it to be curated. So a lot of the questions, unless you want you want it to be out of a maze. Like I'm going to make mazes. What is my maze? So I was going to make like 4-digit mazes, 5-digit mazes, right? Adding and subtracting. I mean, are you like this? Like you want activities like this, Jelio, to improve my mental math? Yeah, but did you want activities? Because I noticed that adults that are coming to Abacus, they want to have activities as well as understanding how to use the Abacus. Yeah, I was going to make more mazes, Char. I'm going to make more mazes. I've got the multiplication and I got the division. But yeah, Jelio, are you talking about something like activity based or you just want a bunch of numbers? You like mazes? Okay. Okay. That would be easy. I can do mazes just for you. And so I can just publish that out. But it's going to be advanced, right? Advanced. So depending on the numbers, right? It would be like, I don't know. I think I would I'd probably go as high as 5 digits. 5 digits times 5 digits. Right? And then that would be for multiplication. That's probably as far as I go. And then there'll be all the different renditions, right? It'll be 4 digits times 1, right? Times 2 digits, times 3 digits, times 4 digits. Yeah, these would all be. Division may be the one I get my own practice. Yeah, for 5. Oh, I'm not good with 5. Yeah, it gets a little cumbersome. But it would only be for a maze and just to practice. But yeah, that would be the idea. And then there'd be the 3 digits, right? 3 digits, and then it'd be the same thing. 1 digit, 2 digit, 3 digit, right? 4 digit, 5 digit. Yeah, that's what I would do. But for multiplication and for mine is fun. Yeah, I could only do 3 digits and 2 digits. Oh yeah, yeah, yeah. But it's the same. Yeah, 4 digit times 3 digit. Yeah. Yeah. So, Satan, sorry. Yeah. Yeah, thank you for being patient. So what are we doing? Understanding how to, yeah, so I guess Vinters is gone. But that's what we're doing. Oh, thank you guys for checking in. Thank you guys for checking in. So what we're going to do is, I'm going to actually sign off. Unless there's more questions, but that's what it was. And then that was the other thing is, after I do multiplication mazes, I was going to do mazes. And then after that, we're going to do division. And I was going to do division mazes. So Char said, division, I may have to get an abacus of my own to practice. Oh, yeah. So, Char, if you're looking for one, I would do the 13 column one, because then you have more room to do your division. That's what I recommend. The 7 column one would not be suitable, because it's too small to put in your divisor and your dividends. Division. Can you do one more? Yeah, I'll do one more. Again, we're going to go simple. We go simple. How does the Chinese work? Oh, yeah. Yeah, thank you, Char. Stay healthy. Start of my day. Yeah. Okay, I got it. You know what? You're right, Char. I'm going to go for a run today. That's what I'm going to do. I'm going to stop complaining. I'm going to go for a run. Okay. Before we go into division, let me talk about the Chinese Suipun work. Yes. So here's a Chinese one, and it's the same thing, and it's very similar. But I was told that they don't do formulas. So, and that's really interesting. In Abacus, Soroban, they use abacus. They use formulas. This is the formula. They need to add the 5 and take away the 5. But now in Chinese, they don't. Which is, now I know why. All right. Yeah. This is how we do it. 1, 2, 3, 4, 5. Because we have 5, we're going to trade it in. We need to understand this concept of trading in. This is 5, so we have that, right? This is 5. We do 6, 7, 8, 9, and then 10. Because we have 5, we're going to trade it in again. That's 5. And then we do trade it in, because this is 10. Because this is 10, we got to trade it in, right? Make sense? So when we're looking, oh, I don't know if that works. Okay, so here, I had a question, and I'm like, how do you do this? And I'm like, there's got to be a, I thought they used the formulas like Japanese, but they don't. They do a lot of counting up. So here's the question, which is very interesting. 7 plus 9, right? 7 plus 9. We have 7 on the abacus. And then what do? Is they count up. 1, 2, 3, right? Because I have this, they're going to change it, right? We're at 3 right now. This is here. We got to change it again. 3, 4, 5, 6, 7, 8, and then 9. That's what they do. They count up. That's how they do it. And I'm like, what? Really? But that's what they do. They know that 3 plus 6 is 9. So that's what they do. So we had 7. But see, I don't know. I now know, I think I have a theory why Chinese abacus would never took mainstream, because you have to count up. Hello, Michael. Good morning, good evening, good afternoon. So yeah, that's what they do, is like they count up. So we have the 3, and then we add the 3. 1, 2, 3. But then, because we have 5 here, we have to add. And then because we have 10 here, we got to trade it. There's a lot of trading. And then they know they've done the 3, then they still have to add the 6. So they add the 6. So then their final answer is 16. It is more steps. It is more steps. It is very different. It is very different. So in abacus, okay, so let's do it. I showed you, right? So in Soroban, all we need to do is plus the 9 is equal to plus the 10 minus the 1. Because why? We know that 9 is equal to 10. We know this. So we take this concept and we modify it. So we have 7 plus the 9. Plus the 9 is what? Plus the 10 is what? Plus the 1 plus the 0. Plus the 1 plus the 0. That's 10, right? And then we take away the 1. And we take away the 1. So my final answer is 16. So my final answer is 16. Yeah. Yeah, it's been very interesting, like going down this path and seeing what other people do. But yeah, somebody was telling me how they did it, because they did it in China, and I don't know if they'd still do it now, but I was like, that's what you do. You count up. There's a lot of counting up, and I'm like, Japanese made it more efficient, because that's what Japanese people do. Japanese people make it efficient. You know, because they just take it and it's just crazy, and it's so elegant when they discovered it. I was like, this is crazy. So Division. Division. We're doing division. So let's do this division. We're going to do simple division because I just want to make sure that we understand it. This is a concept of how to do division, long division on the abacus. So we do 22 divided by 138. Now what we do is we need to understand our divisors and our dividends, right? I'm going to do a label. I'm going to do a label. Oh no, there was my label. All right, I'm back. All right, so I got my labels. I got my divisor and my dividend. Now what we're going to do, triple O, are you still around? We're going to do 3. We have to find our starting point. When we find our starting point, okay, good. When we find our starting point, what is our starting point? You let me know. How do we find our starting point? I don't know if you remember. This is just a test. Because I want it to be interactive, you know? So do you remember how to find it? How do we find our starting point? Ha, 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 ha. Do you remember? Place value, almost. So what we're going to do, we're going to take this number, 3. Our dividend has 3 digits. Because our dividend has 3 digits, and our divisor has 1 digit. So 3 digits take away 1 digit gives me my place value of 2. So when I count, I'm going to count 1, 2. My quotient is going to sit in my tens column. Does that make sense? My quotient will sit in my tens column, and I'm going to sit right here. Now, because my quotient is here, I'm going to use my dividend to track my numbers. I'm going to put my dividend on my abacus. I do 1, 3, 8. It doesn't matter, I have 138. We're not doing place values. This is just a placeholder. We're just going to put it as a placeholder. So my question now is what? My question is 2 times what is equal to 1? Because we need to compare apples to apples, 1 digit by 1 digit. And this tells me if I need to add my second digit or not. Do we have a multiplication fact that says 2 times what is equal to 1? Is there a missing? There's a missing. We can't, right? There's no such thing as equals something times is equal to 1, right? Thank you. Thank you. So what do? We have to bring down the 3. We got to make this into a double digit. To make it a double digit, we got to add the 3. Thank you, Michael. Thank you, Triple. Does that make sense? So now it's a double digit. We can kind of do it. Now we can ask, 2 times what is equal to 13 or less? 13 or less. It's always got to be less. Can't be more, right? It's got to be less because we're subtracting. We don't want to do negatives. We want to subtract. Thank you. 6. So I'm going to put 6 as my quotient. My quotient is right here, 6. And then I take away 12. I have to minus the 12. Minus the 1, minus the 2. I still have, thank you, Michael, I still have some dividends. I can do it again. I can do 2 times what is equal to 1. This is my 1. Can I do it? No. I got to do it again. I have to bring down this second digit. So I bring down the second digit and I get 8, right? So 2 times what is equal to 18 or less? Nine, thank you. So my 9 is my quotient. My 9 is my quotient, and I take away 18, right? So I take away 8, take away 1, take away 8, take away 1, take away 8. So my final answer is 69. Thank you, Benny User. So my answer, if you notice, because I use my quotient, or my dividends to track my quotient, I can now use my place values. I can do 60 and 9. I know this is my 1s. I know that this is my 6 in my 10s. So my answer is 69. How we doing? Did that make sense? That did not make sense, Michael? Was that crazy? That's how we do long division on the abacus. You alright, Triple? This is the first time dividing for me. Oh, yeah. It's a little bit, but it's also a different way of thinking. It's a very different way of thinking. Yeah. Hi, Junior. Thank you, Junior. Yeah. This is my first time learning abacus. Yeah. This is, yeah, it's a different way of thinking altogether. Altogether. So what we do, usually I start off with adding and subtracting, and then, but you've been around, Triple. I've seen you around. I will catch you in another do more. Okay. Yeah. I'm going to head out too. I'm going to go get some breakfast, and I got to let my dog out. And then I was going to continue on. Yeah. Thank you, Michael, for joining. Thank you, Triple, for joining. But I thought you knew adding and subtracting. Have a great day. Thanks for the lesson. Yeah. No, I thought I'd seen you before, Triple. I thought I did. Okay. Thank you again. No, thank you. I appreciate it. And then Satan. I don't know if Satan's still here. Hey, Miracles. Okay, bye, Michael. I don't know if Satan's still here. Oh, hey, Honeybee. Thank you. Oh, thank you. You guys are so quiet. You guys are so quiet. If you guys are quiet, I don't know if you're here. Awesome lesson. Oh, thank you, Benny. Thank you, Benny. All right. How are we doing? Okay, I'm gonna head out. But thank you again. Thank you everybody for joining. I will see you all in my next live, and have a good weekend. If I don't see you soon, I'm gonna head out. I've been lurking for a few days. Ha! I know. I've seen you. See you again. Thank you so much. Thank you so much. Thank you for dropping by, and then let me know if you have any questions, Satan. Please. I don't want you to be confused. Yes, Michael. I am still here, Michael. Oh, yeah, not a problem. Thank you. Thank you for your patience. Are you back later today? Yes. I'm going to go to a barbecue, but I should be back later tonight. It'll be later tonight. It might be 9 o'clock Pacific Standard Time or 10 o'clock Pacific Standard Time. Maybe not that late. Maybe somewhere around 8. I don't know when I'll be back from the barbecue. I might be awake. Oh, East Coast. Yeah. Oh, you're in East Coast. Yeah, I try to come on a little bit earlier because of the East Coast. But it depends on what time I get back from the barbecue, because I have a friend having a barbecue. Thank you, Triple. Thank you, Triple O. But yeah, I try to go on at least twice a day, because I'm trying to abacify the world. And to abacify the world, I have to keep talking about it. Yeah. So, yeah, probably about 9, maybe. Safest bet. But yeah, I'll be on. I'm not very good, so this is exciting. You know, you are going to be very good after this, because this is very visual, and you're gonna, I'm hands down. There's so many people that say that they don't like it, and then as they go through and I show them how to use the abacus, because it's so visual, it's amazing on how simple the tool is, and all we're doing is we're just moving the beads. It's so fascinating. We're just moving the beads, but you're actually doing the calculations in your brain. If you notice, all of these little hieroglyphs that I've been talking about, right? All of these things that I do, these is what happens in your brain, right? You don't need to write it out. I write it out for you so you can track my thinking. But like when you get to know like these numbers and stuff, you don't need to do any of these, like, you don't need to do any of this, because you just need to know how to add the 10. Yeah, I felt my mind blown earlier. Yeah. But yeah, I mean, it looks complicated only because I'm writing it out. But when you start understanding the fundamentals, how to make a 10, how to make a 5, it will be easy. You just need to move the beads. You need to just be diligent on moving the beads. That's it. Because once you move the beads, the answer will be on your abacus. You don't have to memorize your answer. You just see your answer being moved. Yeah, it's fantastic. It's I believe it's the greatest thing next to sliced bread. Even though the trolls are like, sometimes I do convert my trolls. Count accurately. Yes, count accurately. Hello, Alma. Good morning, good evening, good afternoon. I watch you do multiplication and I feel more confident with multiplying. Oh, that's fantastic. That's fantastic, Michael. Oh, yeah. Yeah, it's so funny. Sometimes I convert trolls. It's so funny. And sometimes I convert other people that are like, oh, of course, an Asian talking about math. Of course. But I'm here to tell you the secrets. I'm here to tell you the secrets of math. I only do arithmetic, just so you know. I don't do anything higher than that. But yeah, good, Michael. Oh, so Dan, you know, when I get my multiplication maze book out, I think you're going to really enjoy it. You're going to really enjoy the multiplication book. It's going to be a maze, and it'll be very easy. It'll be very easy. I think you're going to really enjoy it. But I'm excited. But I got to get the introduction to Abacus for adults out the door first before I do everything else, because if I don't, I'm going to get stuck. So, thank you again. For those people that are interested, I do have a bunch of TikTok shop books, and then my books are also available here as well. Hello, my name is Lynette. I've been teaching Abacus for about 20 years now. So, thank you everybody for joining. I don't know how many people are in the room. It's so hard to convince people that they don't need to memorize everything. Oh my God, you're right, Alma. Oh my God. Here. This is so cool. This is what I did. I found this thing. Hey. Good morning, Melinda. Good afternoon, Melinda. Good morning. So, oh yeah, Alma, we were talking about this. I was talking about this. This is going to be great. So, in mainstream math, we do 27. We do 20, right? We do 20, we do 7. Satan already seen this. So then in mainstream world, right, what do? They have to memorize that 8 plus 9 is equal to 17. This is what they have to memorize. But in the Abacus world, what do? Minus the 10 plus the 1. Minus the 10 plus the 1. That's it. So then we do it again. Good morning, Melinda. So we do it again. We do 36. We could do 36 on our Abacus. 36. Guess what? Mainstream math, you need to memorize that 7 and 9 is equal to 16. 7 and 9 is 16. That's all you have to do. You have to memorize it, right? But guess what? In Abacus world, what do? Minus the 10 plus the 1. Minus the 10 plus the 1. How easy is that? How easy is that? Do it again. 48. 48 on the Abacus. 48. And then I want to take away the 9. Guess what? In mainstream, you have to memorize, right? You have to memorize that 9 plus 9 is equal to 18. You need to go up. But guess what? Abacus does minus the 10 plus the 1. Minus the 10 plus the 1. My answer is 39. Thank you, TJ. You would be a good math teacher. Only if I can teach Abacus. We can do it again. Oh, this one was at 8. So then you have to do a whole new set of math facts, right? So we have 55. We want to minus, we want to take away the 4. I guess I should do 6. Because we want to minus the 10. Yeah. Crazy, right? Crazy. Because we could do it again with the 8. You need to memorize that 15 is 8 plus 7. But in Abacus, we just do minus the 8 is equal to minus the 10 plus the 4, plus the 2. Minus the 10 plus the 2. That's it. That's so, it's so crazy. And that's what I found. I found how difficult mainstream math is. Mainstream math is so difficult. There's a lot of memorizing. In mainstream math. I'm too lazy to memorize. I am too lazy to memorize. Melinda, did that make sense? Was that crazy? I know, right? Crazy. Anyways. Yeah, that's going to be... I'm going to try and make a post out of it, but I don't know if anybody would understand. Anyways. Alright. Thank you for the follow. Thank you, everybody, for joining. I am going to head out. Thank you, everybody, for joining. Thank you, Amma. I am a math teacher. I am a math teacher. You're right. And I'm going to own it. I'm going to own the math teacher. Thank you for the follow, Mighty Lake. I'm teaching you math right now, TJ. What do you think this is? This is not just reading. Okay, Michael, thank you so much for joining. Yeah. And I get jokes. Oh my God, Alma, listen to my sound bites.
Come on, do it. Do it.
Here's another one.
Oh, I love it. Great stuff.
Do you know what movie that came from? Do you know that movie? I don't know if Melinda's still here. I think she's left. That's okay. That one came from, what grade do I teach? I teach the fun grade. It's Starsky and Hutch with Ben Stiller and Owen Wilson. And I keep saying do it. And I love it.
Come on, do it. Do it.
And then, you know this one.
Now I know.
And knowing is half the battle.
You know that one, right? TJ, I'm not a school teacher. I'm a math teacher, and I do math on the side. This is my business. So you did that one, yeah. Did you hear this one?
Oh, I can see everything.
And then there's this one.
More than meets the eye.
My sound bites are growing. Oh, do help at least in real life. Yes, trying to build a business out of teaching abacus, teaching math to people. So, but that's where I'm at. Still having fun. Yeah, and still having fun. Okay, but yeah, those are my sound bites. And it's growing. It's funny. My sound bites are growing. All right. So thank you everybody for joining. Thank you everybody for joining. What I'm going to do, well, it depends if I can get enough people to buy my abacus, to learn math, to learn more about math, and we'll see. I'm going to keep trucking away and just keep telling the world how great abacus is. But thank you again for the follow, and I will see you guys all in my next live. Have a good day. You too. Have a good day to you too. Thank you so much. Bye everybody.